This is the Hammond H-111 organ. A customer brought this to me and said, hey, a church gave me this organ and I just really love the way it sounds and I want it to sound as good as possible. Can you help me? And I said, okay. So a bit of history here. The H100 series was produced from around 1966 until the early 70s. And if you own one of these, you either love it or hate it. Most technicians won't touch them. Yes, they had lots of problems from the start. Hammond made a lot of improvements and changes to the design, starting with serial number 15,000. And this one is actually serial number 15,069. Excuse my dogs. Oliver, stay away. So the biggest change between pre-15,000 and post-15,000 was they used to have the percussion circuits as well as the pedal drive circuits in a tube chassis that was mounted here in the middle. And they did away with the tube chassis and they replaced them with two solid state chassis. So that one's percussion and that one's the pedal drive. They also made a whole bunch of improvements to everything, the power supply, the amplifier. All these different circuit boards had minor, some significant changes to improve the way they worked after serial number 15,000. So parts from pre and post 15,000 H100s are not interchangeable. For the most part, they are not interchangeable. It's got the same heart and soul of the more popular Hammond organs. It has the classic tone wheel generator. Interestingly, on this one, instead of having a typical 91 note generator, it has a 96 note generator. There's a few extra treble frequencies. And it has sine wave bass all the way down. That's cool. Now, whether or not you can actually hear that bass is another story, but hey, it's at least the tone wheel generator has them. So I'm going to describe the issues that this thing had when it got here and how I addressed them. The first issue that this organ had was a almost complete loss of signal. After playing it for 5 or 10 minutes, the volume would just go way down, and it might go down gradually. It might kind of go up a little bit and then back down, up and down. It was almost like somebody was moving a fader up and down just randomly. My first instinct was, hey, maybe the power supply is to blame. And I checked all the voltages in the power supply and the amplifier. They were all pretty typical. And so, then I checked the signal coming into the amp, and the gain of that signal was much lower than it should have been. So obviously something ahead of the amplifier was lowering the volume. And I didn't know what it was until I checked out. The problem was that after serial number 15,000, Hammond added an audio delay circuit. Here it is. And the purpose of this circuit is that when you turn the organ on, for the first 10 seconds or so, all of the signals going to the amplifiers are muted. And after about 10 seconds, it lets the signal through. And it does this by applying a negative voltage to 4 MOSFETs that shunt the signal to ground. So there's some capacitors on the board that gradually charge, and once they charge up, the MOSFETs lose their shunting effect and they let the signal flow through. And it's kind of like those time delay relay circuits used on a bunch of hi-fi amps that prevent the loud pops and other noises on power up. But here's the thing. This organ uses a tube amp to power the speakers. that amp already takes, 10 or 15 seconds to warm up, so there's really no point in the delay circuit. So I guess if you were connecting this organ to a solid state amplifier, such as the Hammond Series 10 tone cabinet, sure, you might hear some of those annoying pops and crackles while the thing is warming up, but we're not doing that. So we really don't need that circuit at all. So, I probably could have, at the very least, replaced these capacitors and it might have worked fine, but I didn't do that. I just got rid of it because I had so many other issues to chase. I didn't want to worry about this extra thing that might inhibit the signal and bring it down. And so I removed the board. It was sitting, it was mounted right here in these clips. There is 6 wires, 4 of them going to the various channels, a ground wire and a minus 24 volt wire. And I put some heat shrink on the minus 24 volt wire just to cap it off and get it out of the way. And that's that. Even though I was super happy to have solved the first major issue on this instrument, I knew a lot of the other issues could be caused by aging capacitors. And, I didn't want to blow the budget out on this repair, so I decided to do a partial recap of the amp and power supply and other solid state circuits. So I replaced almost every electrolytic capacitor in the amp except for there's a Mallory can capacitor right up here in the corner. It's still working fine. It had low ESR. The same goes for the power supply. All of the can caps had very low ESR, and there wasn't any excessive AC ripple. And so the exception is I did replace the 1500 microfarad capacitor over here with a couple of axials. That goes to the 35 volt rail. That I did replace that, but everything else I left it be. Most of the axials I replaced. You can see them here. Anything that was blue like this, some of these were so dried out that they were open circuits. This 20 microfarad 350 volt cap is actually being used as a coupling capacitor on the reverb circuit, and it was totally fine. Really didn't need to replace it. Also, any cap that has the white cloth label, those are very high quality caps. They rarely fail, so didn't need to replace those. But all the rails in the power supply, even before I did the recap, they were pretty close to accurate, and they were still working fine afterwards. On the organs that are higher than serial number 15,000, note that the 24 volt rail actually comes from a big fat Zener diode mounted on the amplifier chassis right there. And on older organs, it comes from the power supply. On the solid state electronics, I was careful to replace any of the white plastic molded caps that have blue lettering for the most part. Well, I left one of them, but most of them I replaced. I didn't touch any caps on the harp board. You can see they're all still original because everything on the harp board is working. I guess that could change in the future. One common problem is you might get ciphers where you have a harp note that sounds all the time when it's not supposed to, and well, that's not happening now. And if this was my organ, I'd probably replace all of those, but I'm trying to keep the budget reasonable with this repair. So there's a few caps inside the pedal cutoff circuit, a few caps inside the percussion cutoff circuit that I replaced, and that's pretty much it. the owner of this organ had already replaced the 3 microfarad motor run capacitor, so that's done. That's a major safety concern already taken care of. One of the problems with this organ was the vibrato scanner wasn't working. So anytime you turned the vibrato tab on, on upper or on lower, all you would hear is a constant pulsating static without any actual vibrato mixed into it. So, I'd already replaced a few capacitors on the vibrato boards, and that really didn't change that problem. So most people would have probably said, oh, forget it. But I decided, and the owner of this organ decided, no, I really would like to try to fix vibrato. And one of the reasons is that it's a pretty unique vibrato effect. On the H-100, it has dual vibrato. So you can see over here, we have, this turns on the vibrato upper or lower, and you can change the intensity of the vibrato, but you also have dual vibrato. And what that does is half of the vibrato scanner goes to one channel and the other half goes to the other channel, so you get this kind of oscillating vibrato effect back and forth. So actually kind of nice. Chorus adds a little bit of dry to it. So, it was worth saving. Now, Celeste actually worked great. Celeste is the other feature. You turn on vibrato and you hit the Celeste tab. It's the same thing except much slower. It oscillates back and forth, like once a second or so. Celeste was working, but regular vibrato was not working, and we really wanted to try to fix that. So on earlier models of the H-100, they have both the scanner vibrato and the Celeste scanner are these square-shaped devices. You can see it down there. This here is the Celeste scanner. It is belt driven, and the reason it's got a belt and a large pulley is so that it can spin really slowly. And the vibrato scanner is over on this side. Can't really see it that well. I need to open up this harp thing, but it's mounted to the right side. I'll show you a picture of how it looks in the service manual, but that's where they are. So this is where the vibrato scanner attaches to the vibrato recovery boards, primary vibrato and secondary vibrato. The first thing I did was swap the two to see if the problem of static changed, and it really didn't change. So I figured, okay, well, I guess, the scanner is to blame. Now, on most organs, you can take the scanner apart, you can clean it. It's a real common repair. I thought, how bad can it be? Well, spoiler alert, I was really wrong. It wasn't that hard to get the scanner out. You have to unbolt the generator. You have to untie all of these wire ties. You have to sort of scoot the generator out, and then you can unscrew the vibrato scanner. I also unscrewed this hinge on this harp board, completely removed the harp board so that it was just kind of hanging down and kind of out of the way. There's 4 1/4-inch machine screws that hold the scanner in place. There's a small coupling spring that holds the scanner that drives the scanner from the generator, and there's two little oiling threads. So it really wasn't that hard to remove it, except for just maneuvering and kind of scooting the generator out a little bit to get to it. When I took the cover off, I discovered that the scanner was absolutely loaded with dendrites, little fine crystals like metal hairs between all of the stators. And unfortunately, I couldn't remove the stators because they appeared to be riveted onto a plastic frame. So I tried to spray it down with contact cleaner and some compressed air, and when I reinstalled the scanner, I found that the problem actually got worse, not better. Now, the service manual does describe a procedure you can do to align the rotor pin, and I did try that procedure, but I failed, and there's two reasons why it failed. Number one, I did not have the correct tool, and number two, I did eventually loosen the rotor. However, on this scanner, I found the rotor was jammed on its axle and would not move even after loosening both set screws. These scanners use a 6-lobe Bristol spline set screw, where most other Hammond organ vibrato scanners use a 4-lobe Bristol spline set screw. So you can't use your tried and true 4-lobe tool. The service manual says to use a number 6 Bristol spline wrench. So good luck finding that. I did actually go to Bristol Spline's website and I bought a 7-key set, part number SL607, from Bristol Spline directly. And it got here, and even the smallest wrench in that set was too big. So I guess that was a waste of money, but my loss is your gain of knowledge. Does anybody know what a number 6 Bristol spline wrench is? I'd sure love to know. Moving on. So I tried to disassemble the vibrato scanner, and in doing so, I cracked the frame that the stators were riveted to. So the bottom line is, this vibrato scanner is not serviceable. It might be possible to realign the rotor pin, but in my case, when I did finally loosen the rotor set screws with a star bit, the rotor would not move at all on its axle. So, and on top of that, when I reassembled the scanner, it was totally jammed due to me cracking the stator frame. So I gave up on that and I decided to find a replacement vibrato scanner. That wasn't easy because most of the later H-100, 200, 300 organs use a completely different scanner that consists of 2 black drums. And the drum type scanner was too long to fit on this organ. You know, it would have fit right here, and there just wasn't enough room. Hammond did sell a retrofit drum scanner field upgrade kit for the H-100s back in the day, which mounts both black drum scanners below the generator right here, and it's driven by its own motor. Couldn't really find that for sale anywhere. I didn't really want to completely, I would have had to take the generator out, take out all the screws on the frame of the generator, shift the generator down a few inches so that it mounts to, you know, it shifted down a few inches to give room for the black drums to fit, and that just wasn't going to happen, like no way. So looking for a replacement square vibrato scanner, I did find one. There's actually 2 versions of it. The version I have only has one 9-pin connector, but earlier H100 organs have 2 9-pin connectors because they have 32 poles, whereas this one only has 16 poles. Every version I found for sale was the older kind that had 2 connectors. Mine only had 1. I was about to give up, but at the very last minute I got a tip from a technician in Tulsa, Oklahoma, that there was an H100 being parted out at a guitar shop up there. I got a hold to them. Sure enough, they were parting it out. I got on FaceTime and realized that is the right scanner. Please, you know, ship it to me. Thank you. And sure enough, it works. So the bottom line is I would not recommend attempting to repair these scanners. I've heard that black drum type scanners are also notorious for having noisy bearings and crackling problems too. So if you get one of these with bad vibrato, I would say good luck. I would shy away from attempting to repair the scanners. Maybe try getting a replacement scanner and see if you get lucky with that. Next, the next issue I needed to deal with was a very excessive amount of white noise and rumbling that was basically happening all the time. It was obvious that this noise was somewhere on the input side of the amp. You know, it wasn't being caused by the amp. And the question was, where was it coming from? The noise still happened even with vibrato turned off. So I disconnected the non-vibrato signal. So this board here is the non-vibrato amplifier. And the output is labeled wire number 5. You can see number 5. So up here, number 5, let's see, one of these right here, number 5, I disconnected that signal from the, well, it's here on the Celeste switch, and the noise stopped. So great. I isolated the problem to this, but I wasn't done because this amplifier gets several things sent to it as its input. We get all the drawbars, we get the percussion amplifier, we get the harp amplifier, and we get the pedal signal all going to this. So I desoldered these two input wires and the issue was still happening. So I knew this was the problem. Wasn't something leading up to this. So then I divided the circuit in half. I desoldered one leg of this capacitor C804. I think that's the right one. Let's see. C804. I'll show you on the schematic where it was. I desoldered one leg of that capacitor and the problem stopped. So that told me that the issue was being caused somewhere in the first half of the amplifier's signal. I had already replaced some capacitors, so what I did was I started with the resistors that touched the most DC voltage. R805 and R807 are the 150 kilo ohm and 22 kilo ohm resistors attached to the 100 volt rail. I replaced those and the noise continued. I replaced R804, which was 22 kilo ohms, still had the noise. Finally, I replaced R806, which is that resistor right there, which is 560 ohms, and the noise stopped. And the non-vibrato signal is now loud and clear with no distracting white noise. Next, I decided to attempt to go through all the adjustment procedures that are in the service manual, but I kind of got stuck on step 1 because the gain for channel B was too low. Channel B, of course, is coming out of that speaker. Channel A was fine. I started out by cleaning all the switches, deoxit and flushing them out with some CRC QD. That didn't really help the problem. I measured the signal gain down to the volume pedal, and I found that channel A and B had the same volume here. So to me, that meant that the problem had to be with one of these switches. Interestingly, I found that when I hit main and echo, channel B was loud and clear. That was kind of a clue. I traced the problem to a faulty contact on this main and echo switch. I found that there was one of the leaves on this switch that wasn't making very good contact. And I didn't really want to bend the contacts to force them to go to place or do anything too invasive. But I found that when I gently pushed on the side of the switch, just a little bit of pressure was all it needed to make contact. So you can laugh at me all you want, but I use a zip tie to gently squeeze the two sides of that switch together just enough so that it makes contact when it's supposed to and opens when it's supposed to. It works beautifully. So lowly zip tie to the rescue, You know, technically, I guess I could replace that switch, but I'd have to find a donor, and that's, you know, not really a practical thing right now. Next, I went back through the adjustment procedures, and I found that the bass channel was weak. As it turns out, all 3 tubes on this channel were very weak, so I ordered new tubes. The $71.99 tube hasn't been available for quite some time, and they're very expensive, new old stock. So I'm going to use a 6U8 tube and one of those little $71.99 to 6U8 adapters. That way I don't have to rewire the socket on the amp itself. I'm still waiting on those tubes. The shipment's delayed, and I'm hoping it'll be here soon. But you can see, I think it's a 15-inch speaker, nice 4 ohm 15-inch bass speaker here in the middle, and the gain is like a fraction of what it should be, even though I've turned up the bass channel level. So, you know, weak tubes, what can I say? We're going to replace all 3. Let's see what happens. In the middle of all this, Celeste stopped working. You know, vibrato was fine, but Celeste was like dead, nothing. So what I found was that there wasn't any signal getting to the Celeste drive amplifier due to a faulty dual vibrato switch contact, which is where that signal goes first. And once again, our lowly zip tie came to the rescue, just like I did on the main and echo switch. I put just a little zip tie to very gently compress the sides of that switch together. It works perfectly. Once again, laugh at me all you want. I am not ashamed of that. If I need to clip it out, I can clip it out and try something else. But for now, it's working great. All right, H-100 percussion. So on this organ, percussion almost never worked right. I think it worked one day, and then it just never worked before that and never worked after that. The only way I could ever hear a percussion voice was if I turned on percussion and I hit second voice, which basically sounds the voice of whatever percussion you've picked constantly, like a preset, no decay. That was the only way I could hear it. This is how it's supposed to work. You choose a voice. So I'm going to say xylophone. Notice how, if you're used to playing a B3 organ, well, the contacts are a little dirty, but it lets you reiterate. It lets you reiterate even if you haven't let go of all the notes, which is interesting. That's not how it works on a B3. You have to let go of every note first. If you want to go back to how a B3 works, you just hit touch control, and then it works like you're kind of used to. Okay, so the only way I could get percussion to work at all when it was, you know, not working was to not be in the B natural preset yet, have a tab pressed down on the percussion and hold down a note or two, and then press the B natural preset, and then I could hear percussion sound one time and it would decay and it would never sound again. If this condition sounds familiar to you, you're right, because the same type of problem can happen on older Hammond organs like the B3 and the C3 and the A100. I suspected that there was a short to ground on the percussion keying bus bar, and I was right. So on this model, it applies about 10 volts to the keying bus bar, and it does so through this junction here. And when a key is pressed, it bleeds off the voltage to 0 volts in a controlled manner through a Zener diode. And I measured at pin 3 of the reiteration driver circuit, which is right here. Pin 3 is where the keying voltage should come in. I think it's this orange wire. And it was just 0 volts. In fact, it was always 0 volts all the time. In fact, I measured that pin and it was shorted to ground. So that meant that the input side of the keying bus bar was still 10 volts, but the output side of the keying bus bar after the Zener diode was always at 0 volts. So it had been, it was shorted to ground. So I ended up doing something that I'm not going to show you on video because it's incredibly dangerous. I zapped those bus bars. So this is, I think, this is P603, this plug right here. You unplug it, and I can show you this because this isn't dangerous. Those 12 connections go directly to the bus bars for the upper manual. So what you do is you cancel, make sure there's no keys down, unplug P603, also unplug P602, which is this red one in the upper right, and then unplug P601, which is this brown one in the bottom right. That goes to the lower manual. Get your ohm meter, put one side to ground, and touch the positive probe to each of these. You're probably going to find continuity to ground. That shouldn't happen. So you could take a high voltage source and basically touch the high voltage to each of these pins, and not gonna lie, it's kind of terrifying. You literally zap it. You might see a spark right here, and you also might hear some various pops and fireworks from inside the keyboard. So not for the faint of heart. I'm not going to show you this on video. I don't recommend doing it unless you are an experienced technician only. But hey, it worked. Basically, I took a clip lead down to the power supply at the 100 volt DC line. That's what I used. I made sure to pull the output tubes from the amplifier so that we didn't hear any pops from the speakers. So I pulled out the power tubes. I'm using a Leslie, so I unplugged the Leslie. And I had a lead connected to 100 volts and turn on the organ while these are disconnected. I touched 1 through 12 of P603. I touched, let's see, this is P602. And I touched only pins 10 and 11. And on this one, P601, I touched pins 1 through 10. That's it. And I only had shorts on the upper manual. I didn't have any shorts in the lower manual. So I didn't really zap the lower manual because I didn't need to. But after zapping it, those little crystals that were shorting the bus bars to ground vaporized, and there might still be some in there, but they're not currently touching and they're not currently causing me problems, and Percussion is working beautifully. So there you go. Yeah, don't do this. I would recommend referring this work to an experienced technician, and you're welcome to message me if you have any questions about what I've just described. All right, part 2. Let's talk about this Leslie 120. So this customer brought me a Leslie 120 and said, hey, can I connect this to my H-111? First of all, let's talk about how this organ sends signal out to other things. The organ has 3 built-in speakers. We've got 2 mid-size speakers for the A and the B channel over here and over here. And we got a bass speaker in the middle for the bass channel. But really it's just two channels, A and B, and they both make the same kind of signal. The only difference is that one of them is in a different phase of the vibrato cycle to give that stereo effect. So channel A and channel B are both full range signals. And those A and B signals are able to be sent to a choice of either the organ's speakers or an external tone cabinet or both. And the way that that's done is with these switches here. So main and echo routes the signal to both the internal speakers and your external tone cabinet. Echo only will only send signal to the external and not the internal speakers. I think that when both are down, it's echo only. So that's main and echo, and that's echo only. Okay, so we have three choices. It's basically just like a main ensemble echo switch on a half moon, but in tab form. So the way that works, when you say, hey, go to an echo speaker, A and B channels are sent to their own little tiny preamp stages through a 12AU7. So there's two 12AU7s, which amplify the signal a little bit. And they send it to this weird 7-pin connector, A and B, which is designed for the Hammond Series 10 tone cabinet. So that's how this organ left the factory. And then he brings me this Leslie and is like, make it work. And this is what he brought me. He brought me a Leslie 928 hookup kit, which was originally built for hooking up Lowry organs. It also had the tremolo switch and the main ensemble echo half moon switches. You know, but I had no idea how that kit was put together, but there was only one source of information for the kit, and that is in the Leslie 45 and 47 service manual. There's a schematic for it there. And I knew that if I could install this kit correctly, that would make this organ compatible with any 6W Leslie speaker, including the 45, the 47, the 145, and the 147. So is the 928 Leslie kit designed for the H100? Nope, not at all. The Leslie Speaker Company only made kits to connect two types of Leslie speakers to the H100 series, the 122 type and the model 610. So the 610 is a complicated 4-channel speaker. I won't really go into that here, but let's talk about the 122. The Leslie 122 is one channel. It's possible to connect a Leslie 122 using the Leslie 8216 kit. And that kit has an active mixing circuit, which mixes channel A and B together and sends it to the Leslie. So while I think it would be nice to mix channel A and B together, that is going to be a little difficult to do it from scratch. So I decided let's just focus on only sending channel A to the Leslie. And let's talk about AC power. So you'll notice that this kit has a power cable. And here it is. Excuse my messy workbench. Here's a power cable. Interestingly, it's got a alligator clip for earth grounding it, which I'm not using it, but it's available if you want to earth ground it. That's the power receptacle. I've never seen I've seen a few other kits that do that, but not many. And that power cable also goes in parallel to a little AC receptacle pass through to conveniently plug in your organ. So this is the organ's original power cable. We're just going to plug it in right here. That way we only have one AC power cable exiting the back of the organ instead of two. And that's nice. The coolest thing about this kit though is that it has a relay inside it to power the Leslie amplifier. So if you look at the relay, pins 4 and 5 of the Leslie socket are wired straight to AC, and the flapper of pin 3 goes to that relay. So the relay is used to take the load off of the organ's power switch and power the Leslie amp. And the way it does that is with a 6.3 volt coil, which conveniently uses 6.3 volts of your filament voltage from your organ amp to power the coil. Easy peasy. So we were able to connect 6.3 volts via these two green wires right here. That's the filament voltage for the amp. That is going up to our kit to power the Leslie relay. So now that we have this kit is sending AC power to the Leslie speaker, now let's talk about speed switching. That's very simple. It came with the stock, half moon connector. All it does is make a connection between pins 2 and 3. That's it. That's how every Leslie 145 type works. It does that beautifully. Okay, easy. And the last thing to worry about is getting signal to this thing. So originally this kit used, let me see if I can find it. Oh, I don't know where it is. There was an 8-pin plug coming out of the side of this kit. And I think the purpose of that plug was to connect directly to a Lowry amplifier to get signal, ground, and filament voltage from the Lowry. But there's not really any convenient socket to do that on the H100. There's not really any vacant 8-pin socket we can use. So I cut it off and I removed all but 4 of those wires. All we need are the 2 green ones for filament voltage and the red and the black one for signal. So originally this red wire was going to a transformer that was, I guess, a part of this kit, but it wasn't there anymore, so maybe someone took off the transformer. Anyway, we don't need that. All I did was I made sure that this red signal is going to pin 6 of the Leslie socket. I decided that we're not going to be using the main ensemble echo switch from the Leslie kit because the organ already has it. So the place that the signal is connected is right here. I can show you where that is on the schematic, but that's the same place where pin 1 of this 7-pin socket is. That's channel A output to your tone cabinet, and that's being sent to the Leslie. For ground, I'm using a ground point on the channel A level adjust right there. That's what I'm using for ground. Sorry, these wires are a little bit dirty. So I mounted the 928 box right up here, upside down, and I kind of dressed the wires so that they're coming out from little holes in the chassis of this amp, and I zip tied them so that they are out of the way and not touching the 6 BQ5 tubes and not burning up, and it works fine. So that is how to connect a 928 kit to an H100 series organ. Next, I had to figure out how to make all of this work with a Leslie 120. So it's kind of like the 120 and the 125 are sort of similar. They both have a single 12-inch 8-ohm speaker. They both have a 2-speed motor driving that little single rotor. And they both have a small cabinet connector which houses the speed switching relay and the input plug. that's where the similarities end. This cabinet is smaller than 125. And guess what? On a 125, you could purchase and use a booster amplifier. But on this cabinet, the booster amp won't fit. Now, I didn't know that when the customer brought me his Leslie 120. And my first recommendation was, well, buy a Model 25 booster amp. You're gonna need it. That's when I did all this work to the booster amp and then realized, oh geez, it won't fit. So what do? You know, I considered mounting the booster amp inside the Leslie speaker cavity up here, but the problem with doing that was there was some insulation that was flammable, and I didn't want to put it in there and get too hot. And so I decided to put it in the organ upside down, just so we can get a little more ventilation back here. And I put it underneath the generator shelf with T-nuts. So there's, you can see 4 T-nuts holding it nice and securely onto here. So the Leslie 120 was actually built in a way that pins 1 and 6 could have speaker level signal going to it from an organ console. And so I decided, why not make the origin of that speaker level signal come from the output of the booster amp instead of from the organ. So from the factory, the booster amps got this extra speaker socket. You can see it has, for the input, it has this little pigtail with a male plug on it. And it also has, next to that, an extra speaker socket. And from the factory, that socket is wired in parallel with pins 1 and 6 on the input. And so I cut that and instead made it to where the speaker output of this amp is also running to the extra speaker socket pins 1 and 6. And that way, this is powering this speaker. So if this person decides to upgrade to a different Leslie, like say a Leslie 145 or 147, all they'd have to do is unplug the booster amp from the kit and plug their new Leslie, 145 directly into the kit and just not use the booster amp. So that is how I installed a Model 120 with a booster amp and got it to talk to an H-111.